Thank you very much. My name is Marina Blanco. I'm a student of the last year of my PhD. And today with this presentation that we entitled Remote Sensing as a Tool to Assess Forest Dynamics in a Context of Global Change, I intend to give you like a brief summary of my whole thesis in this text, 10 minutes. So let's see how it goes. I will begin by brief introduce how global change is impacting forest dynamics. Then I'm going to talk a bit about the potential of remote sensing tools to study these changes. And finally, as the core of the presentation, I'm going to talk about the key findings of 3 studies that corresponds to the 3 chapters of my thesis, where we specifically use remote sensing tools to assess forest responses to global change. So forest dynamics are changing because of global change. This is something that is going on worldwide. And in the case of Mediterranean forest, what we're seeing is that due to climate change, specifically because of the rise of temperatures and the droughts that are being more intense and frequent, we are seeing an increase of forest mortality and dieback. But at the same time, we are seeing also a densification of forest cover. So under this context, we are seeing how forest dynamics are changing in our forest, and it's essential to understand the changes, to characterize these changes in order to promote like forest conservation measures or forest management strategies. Remote sensing, well, we refer to remote sensing to this acquisition of information from a distance by measuring emitted and reflected radiation. We measure this information with sensors that we mount on different platforms. Satellites or aerial drones would be like some examples of these platforms. Here you can see a couple of examples. The first one is an RGB image, and the second one is a cloud data of LIDAR. So what is the potential of using this kind of tools for monitoring the forest? First of all, we have like a temporal coverage. For example, we have Landsat imagery from 1984, or we have this satellite that is Sentinel-2 that revisits the same area every 2 weeks. Also, we have a broad spatial coverage, would make it like really cost-effective when we want to study wide areas. Also, I want to highlight the availability. There are like a lot of these remote sensing products are freely available. And also, they are combinable with other data sources for enhancing analysis. For example, we can combine remote sensing with forest inventory. The 3 studies that I'm going to present are the following. The first one, we study structural changes through studying canopy gap patterns through LiDAR data. In the second study, we compare different sensors, and we see which sensor is the one that better detects decline in Mediterranean forest. And finally, in this third study, we take advantage of the conclusions of the second study, and we construct a drought-induced forest decline model. So in the first study, our goal was to characterize these canopy gaps, identifying hotspots of forest opening and forest closing. For this purpose, we use LiDAR data in the Madrid community. With LiDAR data, we got this point cloud in 3 dimensions, and we identify the gaps. These canopy gaps are like spaces between the tree cover. We identified these canopy gaps for 2 years, the 2 years that we have available a LiDAR coverage, and then we compare so we could see which areas were opening and which areas were closing, and we applied this spatial statistics called GetISRG to find this hotspot that were statistically significant. So this is one of the main results. Here you can see these maps of hotspots and cold spots of opening and closings. Since this study is already published, there you can find this QR code if you want to like know more detail about the study. And the main conclusions of this study were that we found a general net forest cover densification. It's true that mainly to the closure of small gaps. And we found like high dynamism. We found a lot of forest closings and forest openings, but it's important that they were not even in the space. So we also saw high spatial heterogeneity in the distribution of these hotspots. The second study is very different. We want to see which sensors were better identifying forest decline because of water scarcity. So we identified in the field different places in the Iberian Peninsula with forest decline and with healthy vegetation. So we got a drone flight over those places, and we identified damage, and then we compare how Landsat 8, Sentinel-2, and PlanetScope were able to identify this amount of damage. The main conclusions of these studies were that forest decline was better detected with Sentinel-2, especially when we use humidity indices, that means using the shortwave infrared band, or red edge indices. The best spatial resolution was at 20 meters, and we also compared this detection with the forest structure, and what we've seen is that we only got like successful detection when we have a canopy cover over 60%. When the canopy cover was lower than 60%, we got a lot of noise, and we were confusing the soil signal or the understory signal with damaged crowns. In the third and the final study that I'm presenting today, we applied these conclusions of the second one to make a drought-induced forest decline model for Scots pine. Here on the right of the slide, you can see a photo that we took in the field. This is Navarra, the Pyrenees, and in 2023, sorry, there was a really intense drought, and a lot of pines are with these problems that they are drying out. So we use Sentinel-2, we use humidity index, a resolution of 20 meters, and we masked all those pixels with a forest cover over 60%. This is the foliation model that we got from the study area. And the main conclusions is that we were able to make or to construct a robust model. We got an R-square adjusted of 79% over test data. We found high level of damage in the Scots pine, so we think we saw that the levels of damage in this area were really concerning. And also we studied the correlation with abiotic variables, and we saw that these abiotic variables were drivers of the spatial distribution of this decline. This is what you can see in the figure, where you can see like 3 classes of decline, and you can see, for example, how the evapotranspiration was much higher in the class with higher damage. So this concludes my presentation. I would like to thank all the people I work with, also the research groups, founders of the 3 studies, and I don't want to forget these institutions that put available their remote sensing products freely available that let us make these studies. The organizers, and of course all of you for your attention. I know that I gave a lot of information in 10 minutes. I'm available like throughout the event for any question or any comment, and also I leave like my email if you want to reach out after the event. Thank you.